So in this video, we'll be looking at a new coding interview question. Now, you might look at the title of this video and think, maybe it's not for me. I don't care about bioinformatics. I just want to pass my coding interview. However, I think this video serves multiple purposes at once, which is a great thing. So firstly, even if you do not care about bioinformatics, you can ignore anything that has to do with biology and see this video as purely a coding interview question. You'll write some code to solve a problem and you'll analyze its time complexity. Secondly, one of the most common questions from students learning about algorithms is where are these techniques actually applied? Well, this video answers that question. Clearly, we'll be applying this algorithm to bioinformatics. Thirdly, and in my opinion, most importantly, bioinformatics is likely to explode in the near future. Only 6 months ago, DeepMind was set to solve the 50-year-old problem of protein folding, which is a problem in biology. Now, a lot of you who got into AI probably had aspirations of building a super intelligent machine. Well, I think there's a more realistic view these days that we're probably not close to AGI, and even technologies like self-driving have hit some serious roadblocks. In fact, according to predictions just 5 years ago, full self-driving should already exist. But I think it's important to focus on the strengths of AI rather than its shortcomings. And it would appear that bioinformatics is one of those strengths. Everyone wants to live longer, be healthier, and cure diseases. Guys, for those of you who are constantly asking about practical applications, what could be more practical than this? Instead of building yet another stock prediction neural network, how about focusing on real-life problems? Now, before we continue on with this lecture, this is just a short reminder that the VIP versions of the following courses will be expiring in approximately 2 weeks. Course number 1, Financial Engineering. Course number 2, PyTorch. Note that you can find the links for the VIP coupons in the description below. Okay, so very briefly, what do these courses cover? So in my finance course, you're going to learn all the core topics in financial engineering. This includes how to model financial returns, alpha and beta, time series analysis, which includes time series forecasting, ARIMA, and the famous efficient market hypothesis, portfolio optimization and modern portfolio theory, the Sharpe ratio, the capital asset pricing model, algorithmic trading methods, including trend following, supervised learning, and reinforcement learning. New VIP materials, including statistical factor models and regime detection using HMMs. The main theme of this course is that it's not just a financial engineering course. Because I mostly teach courses about machine learning, this course is infused with artificial intelligence at every step. This makes it very different from a typical finance course. My PyTorch course will teach you everything you need to know about deep learning from the ground up, including linear models, ANNs, CNNs, and RNNs, image recognition, time series forecasting, natural language processing, recommender systems, GANs, transfer learning for computer vision, and building a stock trading bot with deep reinforcement learning. Now, a lot of people are going to ask, why should I learn PyTorch when I can just learn TensorFlow too? Well, the fact of the matter is, most tech companies and research scientists have already transitioned to PyTorch, including OpenAI, Apple, and NVIDIA. So, if you plan on doing serious work in deep learning, then you might want to consider learning PyTorch. Again, the VIP coupons give you access to exclusive VIP material that non-VIP students will not get access to. The current coupons expire in just 2 weeks, so get your copy today by using the links in the description below. Okay, so I thought we could start with a pretty simple problem. It's called finding a motif in DNA. The problem goes like this. We have one big DNA string and one small DNA string. Our goal is to find the positions where the small DNA string matches the big DNA string. For example, if my big DNA string is GATTACAT and my small DNA string is AT, then my algorithm should return a 2 and 7 since the substring AT appears at positions 2 and 7 in the larger string. So please try this problem on your own, and for extra bonus points, upload your solution to Rosalind.info. When you come back to this video, we'll look at the solution. Okay, so hopefully you were able to write some code to solve our problem. Here's my solution. As input, we're going to take in two strings, s and t. S is the larger string, and t is the substring that we want to find within the larger string. Inside the function, we start by initializing an empty list to store the locations of matches. Next, we enter a loop. As an exercise, you might want to double-check these loop bounds on your own. Specifically, we want to count up to the length of s minus the length of t plus 1. Inside the loop, we index the larger string from I up to I plus the length of t. If this is equal to t, we append I plus 1 to our list of matches. Note that we add plus 1 to I, since the question calls for counting from 1 instead of 0. Finally, we return our list of matches. Okay, so hopefully that's pretty simple. As usual, your coding interviewer will ask you to analyze the time complexity of your algorithm. I'll presume you've already done this, but if not, then please take some time to try it by yourself. Otherwise, let's move on. Okay, so let's say the length of s is m, and the length of t is n. Clearly, we have one for loop, which is O of m. However, the full algorithm is not just O of m. This is because the actual string comparison takes some time. Specifically, the only way for us to know if two strings are equal is to check each character one by one. This check, therefore, is O of n. And since we have an O of n loop inside an O of m loop, this is O of m times n in total. Okay, so I hope this video proved to you that bioinformatics really isn't that intimidating. In fact, it's just the application of the computer science concepts you already know and love. If you like this video, please consider hitting the like button and subscribing to this channel, where I'll be posting more videos just like this. Thanks for listening, and I'll see you in the next lecture.